In the last video, we looked at the ANOVA test, the analysis of variance test for comparing group means. And in this video, I'm going to look at a non-parametric alternative to analysis of variance called the Kruskal-Wallis test. And so we'll look at the same example, so the one on the circadian rhythms, with three different treatment levels. So if you recall, we've got subjects who had light shone into their eyes, a light shone on the back of their knees, and then a control group. And then we looked at the shift in the circadian rhythm measured in hours. And so this was a strip chart of what the data looked like. And then when we did the analysis of variance test, we ended up rejecting the null hypothesis that the population means are all the same in favor of the alternative that at least one is different. And I mentioned that that test relied on an assumption that the variances in the three treatment groups are the same. And in this case, it's certainly reasonable to make that assumption. So we can see in the sample variances, or the sample standard deviations, all seem to be quite close to each other. There's not a huge difference in the spread of the points in each treatment group. So it's reasonable to assume that in the population variances could be the same. If that was not the case, then given that that's an assumption that underlies analysis of variance, if we suspected that assumption did not hold, then we would not be able to use analysis of variance. And so then we would have to have an alternative. And so one alternative is this Kruskal-Wallis test. So even though in this case that assumption is valid, for illustration, I'm going to use the same data set to illustrate how to use the Kruskal-Wallis test. So it's a hypothesis test. So again, we've got our four steps. First step is to state the null and the alternative hypotheses. And in this case, rather than saying that the means are the same, for the Kruskal-Wallis test, the null hypothesis is that the medians in the three groups are the same. And then the alternative is that at least one median is different from the others. Second step is to calculate the test statistic. So to do that, we're going to use this Kruskal.test function. So we'll run that. And then here's the test statistic, 9.4231. Again, the book does provide some details on how to calculate that test statistic by hand. Essentially what you do is you calculate the ranks of the response variable, and then you use this formula here. So we can do that using this code, and we end up not being able to find n. That's because n was up here. So I'm going to have to do a little bit of code to get n. Okay, let's try that again. Where are we? H. There we go. So if you're interested in where that test statistic comes from, this is how to get it by hand, but much easier in practice to simply use this Kruskal.test function, and then there's the test statistic right there. Okay, step 3 is to calculate the p-value associated with that test statistic. So in this case, the distribution is a chi-squared distribution. So we could calculate that upper tail area using this code here, Or again, we can just read off the p-value from the output from the Kruskal-Wallis rank sum test. Step 4, make a decision, draw a conclusion. Decision rule, same old thing, reject the null hypothesis in favor of the alternative if the p-value is less than the significance level. Here's the p-value, 0.008991. That is less than 0.05, so we reject the null in favor of the alternative. So the conclusion from this Kruskal-Wallis test is that at least one of the population medians is different from the others. So not a surprising outcome. If it appears that the assumptions are satisfied, the equal variance assumption is satisfied, then if you do the ANOVA test, which we did in the last video, and got this p-value, it's going to be very similar to the p-value you would get if you did the Kruskal-Wallis test. Where you might get differences is where that equal variance assumption is not satisfied, in which case it's not really appropriate to use an analysis of variance test, and in that case you would be required to use a Kruskal-Wallis test that doesn't have that same assumption, and then the p-value you would get for that test would be relevant, whereas the p-value you get for the ANOVA test would not be relevant because it would be based on an assumption that doesn't look like it was satisfied. Okay, so what we've done in the last couple of videos is we've determined that in this experiment it does appear that at least one of the group means or medians is different from the others. But we haven't yet tackled the question of which treatment means are different. And so that's what we're going to tackle in the next few videos.